Okay, so this will be part 2 of our notes. This is going to be due either Thursday or Friday, the 18th or the 19th, depending on when you are in class next. We were going to do an activity before this. I'm going to push it until after so we don't fall behind. So today we're going to talk about the congruence, the triangle congruence theorems. So these are rules that will prove that two triangles are congruent. So it's just using like those tick marks that we learned about. As we can see up here, just using all of those tick marks without any measurements to let us know are these angles congruent or not. So we're going to start with our first one, and we use 3 letters to represent these. So our first one is SAS. And what this means, what it stands for, is side, angle, side. Now this kind of has to do with the order because it's going to be 2 sides and the angle between them is congruent. And so a picture of this to help us visualize it would be 2 triangles here, and these sides are congruent, and then this angle is congruent, both of them, and then this side. So as you can see, we have an angle that's included in between those 2 sides. And so that's what this congruence means. It doesn't mean that there's one over here that's congruent, an angle. It's the angle that's in between those 2 sides. So these 2 triangles are congruent for that reason. The next one is side, side, side. And so this just means that all 3 corresponding sides are congruent. Now it does have to be corresponding, so they have to be in the same order. So for example, if I draw my pictures here, so this one is to be congruent to this one, this one, this one, and that one with that one. So all 3 sides are congruent. The next one that we have is ASA, which is angle, side, angle. And this is similar to the SAS. This means we have an angle and the side that's included in between them, and then another angle is what is congruent. So we have 2 angles, and the side between them are congruent. So I'm going to draw a picture of this. So that means that we might have an angle congruent here, and then a side, and then these angles are congruent. So we have an angle, and the side in between the other angle is congruent. All right, we have 2 more. Next is angle, angle, side. So this one means that two angles and then a non-included side are congruent. So for this one, the side doesn't have to be included. As we can see from my picture here, I have two angles, and then the side is not in between them. Now our last one is actually HL, and this stands for hypotenuse, leg. And so that just means that the hypotenuse of one is congruent to the hypotenuse of another, and the leg of one is congruent to the leg of another. So these are our 5 different theorems. Now I'm going to make a little note at the bottom. There are a couple that you might think of, but they are actually not congruence theorems, so they're not going to work. One of those is angle, angle, angle. That will not work, and that does not prove. And the other one is side, side angle. And that one will also not work, and that does not prove congruence. So we're going to look at these triangles down here and determine what rule might apply to them, whether or not it would work. Just looking at it, which rule might we think of? So the first one here, I see an angle, a side, and an angle. And if I scroll back up, that is one of my theorems. So I'm going to put angle, side, angle. Here I have an angle, and an angle. That is one of the ones that I said would not work, right? So we're going to say that no, this wouldn't prove any congruence. Here I have an angle, and a side, but the side is not included. Is that one of ours? Yes. So we can say angle, angle, side. And then finally we have angle, side, and a side. That's one of ours that we cannot use. So the letter order doesn't matter here for this one. We cannot use that one. Okay, so those are our triangle congruence theorems. You're going to have to study and memorize all of these. And then in the next notes, we are going to apply it by looking at different problems and determining are they congruent based on any of these theorems.